Good day, my friends.
Morning, Doug.
Howdy. All right. Good to see you all today. We are getting ready for a test tomorrow. Not cool. I think I'll send you guys an email about this, but I think I'll put it inside My Open Math, kind of like the quiz and the project and all that. I'll kind of put a link in there for you to send it to me inside the link. I left class yesterday and sat and graded quizzes till like 5:30 straight and still didn't get them all done. So I got a few more to grade, but I've got probably 3/4 of them done. So I'll get those to you guys early today, just so that you can use them to study. And I want to start off today, since you have now given me your answer. What do I need to plug in for that? Given that you've now given me an answer to your first project, and also just to teach you something, because maybe it'll assist you on the test in some way. I want to at least make sure you know the right answer to the project. So let's take a look at that. And also, I'd just kind of like to teach you some, I consider this class more teaching you math. I mean, it's calculus for sure, but I'm trying to teach you how to think about math a little more holistically. And so I think this is kind of a good problem to do that. So project 1 solution. And you should have found this, well, relatively challenging. I don't think anybody just kind of did it real easily. But I also would like to show you this, just because this is ultimately where algebra comes from. I guess that's the thing I want you to see, or like why you even do algebra in the first place, because it sure comes across kind of sterile in a normal math class. And so let's see. So this equation was negative. I think I'll leave it y. No, let's leave it f of x. So this equation is f of x equals negative x squared plus 10x minus 16. And so I did give you a monstrously large hint. And if you were successful in this, you either thought of that hint yourself or you used it. But again, I was sort of very careful to draw the drawing accurately so that you could take a guess. And so we said that x is around 3.6 or 3.7 or somewhere in there. Like you can kind of tell from the graph, that's a reasonable guess. And so for this point of tangency, and if you, as I said before, if you miss it and accidentally make the point, off the graph, then that means the line doesn't hit it at all. If you accidentally get it a little too far around the corner, then the line actually hits it twice. And so by guessing, one of those two things is going to happen. There's no way around it. It's just going to miss. There's no way to really hit it perfectly. But I want to show you how algebra really comes about kind of in the real world. And then that's really based on this. And so I showed you there's kind of two ways to approach the slope. And so you can say, all right, I'll use the fact that I know 2 points. So based on my guess, I obviously know this point where the sun is in the sky for sure. And then this point over here, because of my guess, is 3.7. I I know that 3.7 is my X, and then how am I going to get my Y? Well, this is a really important part of this, but don't you, to get Y, don't you have to plug 3.7 into the parabola equation to get Y? And so I'm going to do that kind of live. So if I say, okay, great, negative 3.7 squared plus 10 times 3.7, which would be 37 minus 16. I got 34.69, which can't be true. So what did I do wrong? I put the negative in the wrong spot. And I got 7.31. So that means my guessed point is 3.7, 7.31. And again, you're glad I gave you a graph for this, because in a sense I did some work that I didn't have when I first started this problem. So now you have this point and it looks right. It looks like Y would be about 7.31. And so now it's pretty easy to find the slope. You say Y minus Y over X minus X. And so when you do that, 24 minus 7.31 divided by 6.3, I got a slope of, I guess I'm going to have to round now that I look at my calculator. I got 2.649. So maybe I'll carry it that far out. And again, it's kind of important to look at the graph and go, hey, that actually looks about right. I mean, that's pretty close. Pretty close. If I count rise over run, if I find some point on the graph, I'm not going to pull it up in the interest of time, but if I count rise over run, that looks reasonably true. But the problem is there's a second way to find this slope, and that's with the derivative. And so I know what the derivative equation says. Derivative equation says this is negative 2x plus 10. And so in this method, I don't have to even find Y at all. I can just plug 3.7 into that mess right there. Let's see, negative 2 times 3.7 plus 10. I got 2.6. Again, I don't know if you did this, but it's very important to stop and notice. If you stop here and you say, okay, that's the slope. Well, it's a reasonable estimate of the slope. But then when you do it the other way, you realize, oh, those don't agree with each other. I mean, that's sort of proof that you got it wrong. But as I've mentioned before, you don't always need calculus in the real world, in the sense that, hey, they're close enough. Like, isn't that proof that, well, maybe I'll just split the difference and say it's 2.62 or something, 2.625. And then good, let's go from there. Close enough, awesome. But in a sense, this is proof that we got the slope wrong, which means that our 3.7, our guess was wrong. And so let's try, and it's very important to kind of point out, crap, darn. Let's try a second guess. And now I don't know what to do. Like 3.7 was my best guess. And so now it's kind of like, well, do I do 3.6 or do I do 3.8? I don't really know which way to go. So I'm going to go 3.8. And I know the right answer to this, but I just want you to notice, like, if I didn't know, I'd just be guessing, and maybe my guess would be closer, or maybe it would be further. But let's just do all this again real quick. So let's see, what's f of 3.8, negative 3.8. 3.8 squared plus 38 minus 16. I got a slightly larger number, 7.56. So my point 3.8, 7.56. Then I could do the same thing I did before. Okay, let's go find the slope. What's 24 minus 7.56 over 10 minus 3.8? What do I get for the slope this time? 24 minus 7.56, answer, divided by 6.2. I got a really similar slope. I got 2.652. Somebody tell me, why is that bad news already? Why is that bad news?
Because it's It's just another guess, and it's not necessarily giving you the exact slope at the point that you're needing.
It is a guess, and therefore I'm wrong. But based on my previous answer, you actually know something about my guess right now. Remember I said I guessed, gee, it's not 3.7. I wonder if it's 3.6 or if it's 3.8. Like, what direction do I go? You know something about the direction based on the previous answer.
It's further right now?
It's what?
Further?
Yeah, notice it's not inside. It's not inside here. Like, the right answer is probably in between those two. And I got outside this, so I could even know right now that I sort of guessed the wrong way. It's actually on the other side of 3.7, but let's continue anyway, because I'm only doing this to show you where algebra comes from. So then I say, okay, well, great. Then let's go find f prime of 3.8. When I do that, let's see, what is that? Negative 7.6, which is 2.4. I get 2.4. So again, not only is it sort of darn, they're not right, but it got even further apart. Do you see what I mean? Like, I went the wrong direction. And so if I was to guess again, and I'm not going to in the interest of time, I would realize 50-50 chance I screwed up. My third guess is going to now be like maybe 3.6. And then I could just keep guessing and get this right. Well, in this case, because the answer turns out to be what mathematicians call an irrational number, which means a decimal that goes on forever and has no pattern, I'll never be able to guess it, but I don't know that right now. And again, I made this problem up randomly. It's not like I worked really hard to make sure it came out weird. I just made it up randomly, and it was weird. It's going to be weird most of the time. And so you're never going to ultimately guess it. But does it make sense that for all intents and purposes, this is just a practical problem? We don't need to get this perfect anyway. If I guessed a few times and got it close enough, then move on, right? But what I want you to understand is this guessing leads to something. And this is what I think is really important about how where algebra arises in the real world. If you will, what just happened is I took a guess. I had one single guess, and it was 3.7 and 3.8. And then the result of that is I did all this math, and I was just hoping those two things would be equal, right? Well, what if we went back and we said our third guess, because we're mathematicians, is I'm going to guess x is equal to a. I'm not going to guess. I'm just going to say x is a. In other words, and I know now, and the good thing about guessing is not only do I see what to do now, and I could never have written an equation for this before, but after doing this 2 or 3 times and hoping they're equal, I actually now know what to do with this number when I wouldn't have known before. And then secondly, I know the right answers. It's below 3.7 now. It's close to 3.7, and it's a little below that, which means if I make some math mistake, then I'll know. So my question is, well, what did we just do a second ago? What did we just do with that number? Well, wasn't the first thing we did go and say, okay, well, what's the y value to get our point over here? We needed to get our y value, and so we plugged a into that equation, and we plugged a into this equation, right? Plus 10a minus 16. So that means our point is a and negative a squared plus 10a minus 16. Isn't that what we did a second ago? There's no such thing as math with letters. So I can't actually push any calculator buttons when that a isn't 3.7 or 3.8, but isn't that what I did to get my point? And so then to get my two slopes, don't I just keep doing what I did? I did 24 minus the y coordinate, which is now a formula, over 10 minus the x coordinate. And so there's the slope one way. And then the second way was f prime of a. So that means just plug a into that slope equation. So it's negative 2a plus 10. Now here, I was hoping these were equal. Now I don't have to hope. I can just set those two things equal to each other. I can say, well, I need negative 2a plus 10 to be equal to 24, and I'll distribute that negative sign, plus a squared minus 10a plus 16 over 10 minus a. You should get very happy when you see that as an algebra student. Why are you happy when you see that?
You can find out what the value of a is.
Yeah, force them to be equal. There's only one letter in it. You have one equation with one unknown. You can solve that. You can make them be equal. This is why algebra is cool. Instead of sitting there lamely guessing, like algebra is a time saver. I'm saving myself time here. So now if I just solve this, and maybe you're good enough at algebra to see the handwriting on the wall here in the sense that I don't like fractions. So I'm going to multiply 10 minus a over to this side, and I'm going to march through a little of this. See, 10 times negative 2a be negative 20a. 10 times 10 is 100. And now I could do it negative a times negative 2a is plus 2a squared. And negative a times 10 is minus 10a. And on the other side, I have a squared minus 10a, and then I have a 24 and a 16, which is 40. If you didn't see it before, you see it now, which is, hey, this is a squared equation. This is not hard to solve at all. This is the quadratic formula. Quadratic formula works best when you get everything on one side. So I'm going to move all this junk over here. So I have subtract a squared from 2a squared. I have a squared. Let's see, what about all my a's? If I add 10a to this side and add 10a to that side, that goes away, and that just leaves minus 20a. Oops, got excited. Minus 20a. And then let's see, whole numbers. I got 100 here and 40 here. I think that's all my constants. I subtract 40 over there, then that'd be plus 60. And now I can ask. And by the way, and like on quizzes, on tests and so forth, I've told you before, if you get to the place where you have the quadratic formula, I hope you have this in your calculator, but at least tell me that. I want to know that I used a program in my calculator. I was grading one of your quizzes yesterday and somebody told me that. And I was like, and I said, I'm giving you credit for your work. So make sure you tell me that stuff. So I'm putting in 1, negative 20, and 60, and it goes into the quadratic formula. And oddly, I get two answers. A could be 16.32, and I guess I should say approximate. And by the way, you don't have to say approximate. A is approximately, oh, there's the one I'm very interested in, 3.675444468, and it goes off the page, and I don't know that. But you could write this down and say, well, you know the quadratic formula, A is equal to negative b plus or minus the square root of b squared, that's 400, 20 squared 400, minus 4 times 60. So 400 minus 240 is 160, all over 2 times a. And you should be good enough even to simplify that down. Let's see. Oh, I don't know if I am. Well, at least I can take a 4 out of 160. Since 160 would be 4 times 40. The square root of 4 would be 2. And then I can cancel all those 2s. So I'd have 10 plus or minus the square root of 40. That's a really nice answer. So like there's the exact answer for A. And so for the first time I know, oh yeah, that's a square root. Those go on forever. That's what mathematicians call an irrational number. I never would have guessed this exactly right if I had some nerdy math reason to do so. And of course you can simplify the square root of 40 further, but actually now have an equal sign, which is really powerful. Anybody have an answer to this? Why would there be two answers to that? That doesn't make any sense at all.
Because it's a parabola.
Yeah, but I don't think that solves the whole mystery. I mean, what this is saying is there's two places where the sun's rays hit that mountain tangent. It's not, so X is 16. What? Well,
it hits the parabola, but it's just outside of a range. So it would probably be like negative 200 or whatever, and way underground in our term.
nice job. In other words, doesn't this parabola keep going right here? And so wouldn't there be a place down here when the parabola got steep enough that it would hit it tangent again? The answer is yeah. There actually is two places where it's tangent. But yeah, that second one. So it's not that one kind of doesn't exist. It's just underground, as Logan correctly said. So that's not the one I'm after, but it actually is a tangent to that parabola, which is actually rather interesting. And so as far as what I'm about to grade, I don't care what you did with this. As long as I see as long as I see this calculation in here, like this is a calculus problem, you have to get the derivative involved or you're not going to get this right. There's two ways to get the slope. And those two ways are what make it possible for you to have an equation and force them to be equal. I don't care if you proceeded with a rounded off number. You didn't have to do your math with 10 plus the square root of 40 or 10 minus the square root of 40. I think it's plus, isn't it? No, it's minus. It's actually 10 minus the square root of 40 is the one we're after. Because the square root of 40 is like, the square root of 36 is 6. And so it's like, that's where I'm getting that 3-point number. So you could, you should be good enough in algebra to proceed with that as your exact answer. And if you did that and you figured all this out, good for you, because this is no joke. But of course, now that you know this, you know what A is. And so then you can now you can actually find the slope. So you can say, and I think I'll find it what I consider to be the easy way, which is I'll use f prime of 3.675, and I'll just, tell everybody I'm rounding this off. That's the easier way to find the slope than going 24 minus y over 10 minus x. I'd rather just plug 3.675 into that f prime equation back up here, negative 2x plus 10. So if I say negative 2 times 3.675 minus 10 plus 10, it's a good thing I looked, plus 10, I get 2.65. So this is my slope. So I now actually know the slope of that sun ray that was perfectly tangent. And now, and keep in mind what my overall goal was in this question was not to find the equation of that tangent line, but just to kind of figure out where is that hitting right there. And so in order to do that, if I actually knew what the equation of this line was, that would be good. I could know that equation. So let's see if we can find the equation of the line, the equation of the sort of the sun ray. Well, now I know that it's y equals 2.65. And again, maybe I even want to tell everybody, hey, I'm approximating this. And let's see, in order to find this, I've got to plug in the 1 point that well, that's not true. What points do I know? What points does this go through? I was actually
1024, the one we found.
Yeah. I was actually about to plug this one in and I realized I didn't know the y coordinate and I approximated it. And then I suddenly remembered, hey, wait, there's this other point up there that I know exactly, 1024. Why don't I use that one? It's perfect. And again, that's why I'm answering this, because even if you got this right, maybe I'm saying things that are helping you think a little bit. So 1024, so that'd be 24 minus 26.5, 24 minus 26.5. I got negative 2.5. So again, approximating. And as I said, you should be capable of doing that with 10 minus the square root of 40 and get it perfect if you want to. Good for you if you do. But like, what good is that now? Like, why do I even need that equation? Is that something that makes sense to you? Why do I need that?
Because now you can set the y value to 0 and then figure out what the x value is where the shadow is actually touching the ground.
Couldn't be said any better. The one thing I know about that point for sure is that it is something 0. I know y is 0. So I can find that y-intercept by just saying, oh, look, based on the point that I just drew, that y has to be 0. So if I stick in 0 for that and solve this, I end up taking 2.5. I add 2.5 to the other side and then divide by 2.65. So what's 2.5 divided by 2.65? And again, because of the graph, I see that I get 0.943396. And it's kind of stupid to round that many places because I already chose to round the slope way closer than that. So to somehow act like that's accurate to 6 decimal places, that doesn't make any sense. In a sense, I'd really have to stop right there at 0.94. But again, because I gave you an accurate graph, you have the ability to look at the graph and go, hey, look at that. That is actually a little less than 1, like the graph showed it was. And so you could sort of know that that's right. And so this is the kind of the ultimate answer. I don't give these projects, I want everybody to get these on their own power, but it's not something to stick in the grade book. So I'm going to answer these every time and talk about them a lot, because if you spent a bunch of time with this and didn't get it, maybe something that I just said is kind of like goes into you a little deeper now. But honestly, the main thing I wanted you to get out of this is you probably stared at this and didn't know what to do for a long period of time, some period of time to maybe the entire time, because this is a fairly challenging question. But do you notice how I got to a way to find it by guessing and checking? Most people stare at stuff that they don't understand in life, in every element of life, not just math, but marriage and job problems and everything else. And they don't know what to do. So they just stare at it, waiting for lightning to strike and, or somebody to come and tell them or whatever. But it's like you can make a lot of progress by just guessing and checking. If you guess and check at this 3 or 4 times, you start to learn what's going on. And then you suddenly become able to write an equation like this when there's no way I can't do this. You can't just stare at this problem and say, oh, I'll just write that equation and solve it. But it's super easy to write it if you've guessed once, twice, 3 times, and then say, okay, now, and I keep hoping these are going to be equal, and I'm honing in on the answer, but is there some way I can make them be equal? Well, algebra is math with letters. It's when you go back and say, I'm not afraid to make my guess A and then do my math with A, which is actually easier because there's no such thing as math with A, and create an equation like this. And in a sense, that's the power of what algebra does. In the end, it just saved me a bunch of time. Does that make sense? I did not do algebra. In the real world, you don't do algebra just because you think, oh, that'd be really exciting to see if I can reach in my pocket and figure out how many coins are in there. And all I know, all I know is how much it's worth. And I can feel that there's 6 coins, and I know it's worth $1.76. And so it's like I can make an algebra problem and find the answer. That's dumb. Pull the coins out of your pocket and count them. But like in this case, it actually saved me time, and there wasn't another way to do it. Like that's where algebra is really cool. So even if you got this right, I hope you learned something from that
Mr. Gardner,
discussion. Any questions or comments before we?
I misunderstood the question. I thought we were supposed to stop at where the sun hit the mountain, not where the sun hit the ground.
Mm-hmm. And I can't remember. Maybe I didn't do a great job in wording the question.
I think I did that too, because it said like the top of the shadow, which I get could mean the top of it at the ground, but I locked onto the top of the shadow, so I found the point that the very top of the shadow would form, and then
yeah. And so you found the point and said, "Sweet, I'm done." Having said that, and if I look at my question and think, yeah, I can see how I'm glad you guys said that, because if I can see that I didn't write that clearly enough for you to interpret it, I can grade it accordingly. But in a sense, notice you had to do all the hard parts of this to find that point anyway. The rest of it was actually pretty easy mathematically to work your way down to where it hit the ground. And so, yeah, if I didn't say on that problem that I want you to figure out where it hits the ground. I know I said it when we were discussing it in class, but that's a lot to take in when you're just reading this for the first time and so forth and trying to make sense of it. So I'm glad you guys both said that, because I'm totally workable to that. So.
I mean, you did put ground on there, but it says the x-axis of the ground. I understood it, but I could see how it would be hard to understand. Just like, I don't know. Sometimes things are weird to read,
Yeah. And I'm perfectly willing to, take credit for my mistakes, like in a test question or something that I write, if I didn't say it clear. And especially if you've proved yourself, like after I get to know you a little bit better, like we're halfway through this class or we're into next term and you're like a butt kicking hard worker and you always do your work. It's like, you bet I'm going to trust you on stuff like that. So I'm glad you guys said that, because I don't entirely blame myself, but I think I'm to blame because I don't think that was as clear as it could have been, especially when 2 of you said that. So good. Speak up. The other thing I want to say is, like, don't just let this stuff wash over you. I mean, people do this constantly in math classes. They sit there and think, gosh, this is just hard. And, everybody else must be doing fine and I can't do this. And so I'm just going to sit here and just let it wash over me, let the tide come in and I drown. Like, bug me about this. I don't want you not to get this because it's so frustrating if you're given a problem and you can't get it. Like I want to give you hints, but you've got to take the bull by the horns and ask me questions, because I'm not going to just lead you through it. It doesn't do any good. You don't grow in strength if you don't lift this weight yourself. So as I've said before, I have to strike a balance. This is among the harder ones. I actually have other projects that I'm given, and this is probably harder in the sense that it asks for a lot more creativity. And as I said, speaking the language of algebra, how do you write equations for yourself? That's really hard to do. But it's just such a neat problem, because all it is, it all just came back to me walking on a river with a shadow and just asking a natural question like, that's weird. How in the world is that shadow outrunning me? And this is what resulted from it, just because I'm a curious person. Like, how does that make sense? How did that work? And in a sense, by the way, I haven't even answered that question yet. Like, how does the speed of the sun setting determine the speed of the shadow racing along the ground? Like, we haven't even answered that, but at least we understand how to get the shadow to hit the mountain. Like, we barely even started this problem ultimately. So we aren't going to revisit this question again, but I will show you how to tackle that aspect of it later on. Anywho, that was fun. What else? Anything else about that bug you, make you curious? So all these are the quizzes that I graded yesterday, and I downloaded them and wrote all over them and so forth. And so I'll be emailing those back to you today after I get out of class, so you can learn from that before tomorrow's test. But I want to continue our discussion, and I was going to show you a video on this, but I decided not to because I think we're going to run out of time. But you can go watch this yourself on your own if you want to. So again, what does calculus have to say about this? In 2011, this dude named Tyler decided it would be a good plan to kayak off this waterfall. And I show you a picture that I found on the internet really quickly, because it's called Palouse Falls and it's 176 feet. And that's the world record waterfall in a kayak. And he beat the previous record by like 70 feet. Before, it was creeping up like 4 feet at a time. People did 80 and then 84 and then 86 and then 89 and then 93. And somebody did 104. And then this guy's like 176, like just destroyed it. Like, nobody even really talks about kayaking off waterfalls anymore, but go Google search and watch the video of him going off this. I have it up, but I just didn't want to take the time because I spent more time on that other problem than I thought. But what's interesting about this world, because I'm a kayaker, is most of these people are not as much idiots as you would think. I mean, your response right now should be, you got to be kidding me. Like somebody, I mean, you do realize how big 176 feet is, right? A story on a skyscraper is 10 feet. So this is going off of a 17, 18 story building. So, you know, why would you do that? Like, how does that make any sense at all? But these people are pretty studious, and they check this stuff out. If you do watch the video, he only makes it down to about here before he actually disappears into the water, and you can't even see him again. And then his friends, you can see a couple of his friends in the lower left-hand corner down there, hoping that he doesn't die, and collect him. And he's like, doesn't exist for about 20 seconds there. Nobody really knows where he is, and he pops up and doesn't die. And he got pretty lucky, I'd say.
I'm assuming there's like a pool underneath this, right? It's not rocks underneath it.
And that's the beginning of the studious part of it. Like, they check to make sure there's not rocks at the landing. Like Mill Creek Falls, if you've ever hiked there up in Prospect, is about the same height. No, it's not. It's 76. It's 70 feet. But it lands in rocks. So, you know, that's not runnable. But there's all kinds of things about, you know, what angle to land at, what to do with your paddle so it doesn't hit you in the face, how to keep your paddle from breaking, and how to dissipate that force. So, you know, I'm a little curious, but it's like, how much do these folks, you know, look into this kind of thing? Well, I only bring this up because, well, this is, again, another example of calculus could contribute to this discussion. I'm sort of guessing based on the mentality of these folks that they didn't do this, but maybe they got some nerd friend that did it for them. I don't know. Do you know this physics equation that, let's see, all of a sudden I'm afraid I'm forgetting it. that height as a function of time, because this is 176 feet tall, that's a physics equation, and I won't go into that. But that's a physics equation that will tell you where you are based on time. Now notice at time 0, notice the equation is working. At time 0, that would be 176 feet. And so he's already going down the falls in this picture, but you know, whatever, half a second ago when he was at the top of the falls at time 0, when he first dropped over the edge, he was 176 feet in the air. Well, notice one question that would be extremely interesting to answer would be how much time to the hit at the bottom. And of course that'd be good because when you land, you got to be in a certain position. Like even if you jumped off a bridge, you don't want to land flat, like you want to land straight up and down. And so if you got some way you want to go into the water, like you know how much time. And as I mentioned, he disappeared into the falls and essentially didn't know where he was. It wasn't like he could see the water down there and go, here it comes, I guess I'll get ready. And so does it make sense if he was kind of doing the 1,000, 2, 1,000, 3, 1,000, and he knew the hit came between 3 and 4 or something like that? That'd be cool. Well, this is what algebra is for. This is not calculus. This is what algebra is for. So you could do that. Well, related to the project, what are you going to have to do to solve that from your algebra skills?
Set h of t to 0.
Exactly. Set h equal to 0. And so you'd say, okay, that's really easy to solve. Notice because there's no t term, there's just a t squared. You don't have to use the quadratic formula to solve that. You could just subtract 176, divide by 16, and take the square root, which I know you know how to do. So I'm just going to at least answer it real quick because I think it's just interesting. So subtract 176, divide by negative 16. I got t squared equals 11. So if I square root 11, again, notice it's kind of funny that the answer to the time is a decimal that goes on forever. So we'll just round it to 3.3 seconds. So he could have done that math. Now, what else could he do? What else could he do? Because math is dumb and waste of time and you don't need math. How could he get the same answer by not doing this, not doing any of this math, not knowing this equation, not knowing algebra? How could he get, how much time is it going to take to fall?
By finding the derivative?
No, he doesn't know any math. He thinks math is stupid and he doesn't need it. And he's right. You can get this answer without math. How do you get it?
Throw a rock off the edge.
Exactly. Throw a rock. Turn your timer on your phone off. Good for
That's what
you.
all those guys do. They're always those base jumpers and stuff.
Exactly. And I say good for you. I'm not a person that, tries to make applications where they don't exist. I say good for you if you threw the rock off and timed it. It turns out it doesn't matter what you throw off, unless it's a leaf because of the wind resistance. A leaf is going to take 10 seconds to land because of wind resistance. So you got to throw off something solid and fairly aerodynamic, I guess, like a rock. A rock would be just fine. And of course, it's not like he's looking at his watch going 1,002. Like you just got to count this in your head anyway. So it is cool though that you can get this right based on physics, but it's also cool that you can get it without that. That's awesome too. And even the height is an interesting one. I won't go down that road, but it's like, how would you even know the height of the waterfall? I said 176. Do you look that up in a book someplace, or do you hang a rope off of it and pull the rope up and then measure it on the ground? Do you drop a rock and time it and use a physics equation? And there's all kinds of things that you can do. But
You can use
again,
trig.
go ahead.
Oh, I was gonna say, I know most accessible waterfalls have like a little plaque that says how tall they are. Especially, it looks like it was from a viewpoint, so there's probably like a thing that says that.
Yeah, if there's a viewpoint there, then there's going to be a plaque right up there. And there, by the way, there's a road. This picture is being taken from a overlook. Like there, you can stand there at the fence and take pictures of it and stuff. But again, I asked you the question from yesterday, a little more practical. Like, what would calculus contribute to this? If you did know what you know, what could you learn that actually is worth knowing here? And I'll be a little blunt and say, if you didn't get yesterday, if you don't know the answer to this, you're a little behind. Like from yesterday's discussion, I don't necessarily mean immediately, but you should know what a derivative is. And the units here, notice the height is in feet and the time is in seconds. Notice it would make sense. You're not going to measure the time in months on a jump like this. And the height wouldn't be in miles when it's only, feet tall. It wouldn't be in inches because that's too accurate. But you know the units. Therefore, if you don't understand what a derivative is, then you don't know what the derivative tells you. But from yesterday, you should. Somebody tell us.
How fast you're going when you hit the water?
Isn't it not dy dx in this situation, but dh dt? And do you agree with Logan? He thinks it's how fast you're going when you hit the water. Do you agree with that? Do you disagree with that?
Yeah, because you can find your rate of change at any given point on that fall with calculus.
Since height is feet, isn't this change of feet versus change of seconds? So feet per second? Yes, that's a speed. Logan's exactly right. And not only can you find your speed when you hit, you can find the speed anywhere. But to Logan's point, you don't care except for when you hit. Now, why would you actually want to know how fast you're going when you hit?
Because you just fell 176 feet and you want to know how hard you're going to hit the water.
Yeah, I mean, actually, you should probably do some math here because this guy hooked himself off this a little bit. I don't know if he did this math. I don't know, but it's like, I mean, if you're in a car and you hit a tree, if you're going 30 miles an hour, you might be okay. If you're going 80, you're probably going to die. So
Probably wanted to know if his kayak could withstand that much force.
exactly. Like, will the kayak withstand the force? Will the paddle break in half? Can a human body go from zero or go from however fast he's going to zero in a short period of time and not die? Because all your body's going to stop, but your internal organs keep moving for a second. And so, does that tear your internal organs apart? I mean, I hope you did some calculations. What happens to the human body when it's going this fast? What are your guesses, by the way? Maybe some of you skipped ahead, but like, how fast do you think he'd be going? The only way I know speed is miles per hour. Is he going like 10 miles an hour? Is he going 30? Is he going 60? I actually don't know. I haven't done this problem. What's your gut reaction?
I was going to say 60, something like that. But I was also thinking like once he hits the water, because it's being displaced by the waterfall hitting it, it would actually be like, it wouldn't be like hitting a solid surface of water. It'd be more like hitting, a softer version of the water, I guess, because there's bubbles that are moving it around,
Yeah, like a mattress. And one of the big parts of waterfalls is don't land flat, because if you land flat, you're going to stop faster and your back is vertical and so forth. If you can land pointed, then you're going to punch through the water and that's the same principle of an airbag. And if you take physics or you take my engineering class, we talk about impact. Impact is a physics term that talks about basically speed versus force. And if the force is spread over a longer period of time, as you go from the speed you were going to stop, if you can make that last over like 0.7 seconds instead of 0.2 seconds, then you won't die. And so that's what airbags are doing and all kinds of other safety features. Anyway, so let's take the derivative of this. Well, this is an easy derivative to take.
I have a question for this.
Yeah, go ahead.
So I get that basically his change in feet over his change in time, but wouldn't there also be the factor of the waterfall accelerating him too?
No, because as soon as it leaves the end, like if you looked over next to you and there was a drip next to you, it'd be like, hey, drip, how's it going? And you guys would be falling at exactly the same time.
I meant once it
You could
starts.
have a 3.3 second conversation with the drip next to you. So it isn't speeding you up or slowing you down. It's all following at the same exact speed.
Gotcha. I was just thinking once he like disappears into the waterfall, the added weight of the water on top of
True.
it.
Yeah. Once you come to a stop,
acceleration.
you're now getting pounded on the top of your head. And so, upon landing, I'd say, yeah, now that's an issue for sure. So do you agree that h prime of t is kind of, and that's one of the things you'll see in this section, and mathematicians always use y's and x's all the time, or f's and x's, but it's like the real world never uses y's and x's. It's h's and t's or something. And so, okay, well, that's an easy derivative to take. 176 is, well, the derivative of that is nothing. That seems weird. Nothing. The 176 has nothing to do with the speed. You got to be kidding me. That makes no sense. And then I guess that would be the derivative, wouldn't it? According to the power rule. should bother you that 176 is not part of this. Like you're telling me 176 has nothing to do with the speed. The answer is, well, it does. It does have something to do with the speed. Notice the recipe for speed involves only time. How long have you been falling? But where did time come from? Didn't time come from 176? So it's a part of this. Well, notice it calls for time. Well, don't I know the time? It's 3.3 seconds. So if I figure out what h of 3.3 seconds is, negative 32 times 3.3, and this might be a place to carry that 3.3 out a little further, but we're just rounding things off here anyway. So I got negative 105.6. And again, all of that is not new to you. The only thing that's new is that you understand that the units of this are feet on the top because slope is a fraction. And this is the downside to h prime as a way to say derivative. dy dx or dh dt in our case is way better because it helps you remember that the top is a height and the bottom is a time, and my height is in feet and my time is in seconds. If you don't add feet per second to this, you're doing nothing. You understand that? Like some physics teacher might say, good job, you got it right, but you don't even have any idea what you just did. Now, I don't know about you, but I get that time and I get that speed and I think that's awesome, but I don't even know what that means. I don't speak feet per second. So I only speak miles per hour because I drive a car. It does mean you fall 105 feet in 1 second. That's pretty fast. But I find myself wanting to convert that to miles per hour real quick. Notice it's negative. Is the negative important here?
I mean, yes, because you're going down, but it's not, your speed is still going to be a positive number.
Yeah. And this is what, if you take physics later on, this is the distinction between speed and velocity. You would say he's going 105.6 feet per second, and it'd be like a duh that he's going down. You don't even need to say that. So I actually love Justin's answer to that. So speed is just 105.6 feet per second. Speed is speed. There's no such thing as a negative speed. But the negative is included to help you understand direction. And so velocity includes direction. It's speed and direction mixed together. And so physics nerds make a distinction there. And so it is at least telling you it's going down. And you're like, well, yeah, of course it is. Gravity goes down. And so just out of curiosity, before we quit, I'll just get rid of the negative sign since we decided that's a duh. And I'm going to write feet per second. Again, I'm just asking you algebra questions that you should know. Can you convert this? Actually, you do this for me, like some of you can. How do you, this is one of the most important skills that math can teach you. How do you convert this to miles per hour, since that's kind of maybe the language we speak? What do you have to do to that? So important for physics, where you get units like joules and you don't even understand what a joule is, or you're in chemistry and you get moles and you're like, what the heck is a mole? All these units, I don't even know what they mean. You can get them right just by knowing math.
Well, you would either have, I think you'd have to convert it to miles per second, correct?
Yeah, the key is just work your way over there. Like, how are you going to get seconds to turn into hours? Or how are you going to get feet to turn into miles? Well, look at the units. If you got feet on the bottom and miles on the top, then don't feet cancel and now you're in miles? So now you just got to get on the internet and figure out how many miles are in a foot or how many feet are in a mile. And you discover that in 1 mile, there's 5,280 feet. Perhaps some of you had that memorized. And then you say, okay, well, I'm in seconds. I don't want that. So seconds have to be on the top so they'll cancel. And then I need hours to appear on the bottom. So I need to know how many seconds are in an hour. Get on the internet, find out how many seconds are in an hour. In 1 hour, there's 3,600 seconds, because there's 60 seconds in a minute and 60 minutes in an hour, 60 times 60. And so this tells me, oh, cool. All I got to do is take 105.6 and multiply by 3,600. Do you see how the algebra tells me what to do? I take 105.6 and I multiply by 3,600, and then I divide by 5280, it turns out, and I get 72 miles an hour. Does that surprise you? So for me, that feels like, oh, so like I'm on the freeway and I'm going the fastest you can go without getting a ticket, and then I'm just suddenly going to hit something. Okay, I think I'm gonna look into this a little more before I go off this waterfall. Like, I need to know a little more about the physics of how a boat's gonna hit the water. Like, will it sink in and dissipate some of that energy, like some of you were saying, or is it just gonna land and stop? Because if I'm going 72 in my car or on a bike, let's say motorcycle where you don't have airbags, if I hit a tree at 72 on a motorcycle, game over. And this guy's just doing this voluntarily. And so, do you see what I'm saying? Like, actually, it turns out calculus was probably the most important part of this question. Would you agree with that? You see what I'm saying? Like, but you don't do any of this if all you do is take the derivative of tangent. Like, the book completely misses the point, or books completely miss the point. Calculus adds something utterly foundational to this discussion, given that this, dude decided this would be a good idea. If you don't do calculus here, you don't learn the most important part of this, which is, I think I'm going to wait a few weeks and study a little more before I decide I'm going to jump off that waterfall. Highest waterfall I've done was 25 feet, and I had a sore neck for like a week after that. So it's a little hard for me to imagine this. This is 7 times as high as that. Interesting.
That's crazy that the last second that he counts in his head, he's dropping over half the height in just that last.
Yeah. Yeah. Notices all kinds of stuff. Like, you can find the speed at any different time. You can calculate, where he is at any one of those times, but you're exactly right. He's not halfway down in half the time, because his speed goes from 0 to 72. He works his way from 0 miles an hour to 72 miles an hour. And you're exactly right. The majority of that is happening near the end. I won't go into this now, but there's a bunch of beauty here too. Any of you physics people maybe remember that 32. That has to do with the constant gravitational pull of the Earth. Like, this is what happens every time if you're on the Earth.
That's where the 16t squared comes from, correct?
Mm-hmm. So if you're on another planet that was smaller, then that would be smaller than 32. If you're on a planet with more mass and therefore more gravitational pull, that'd be bigger than 32. If that was bigger than 32, then you'd be going faster, if you will, on that planet. So there's just a bunch of cool stuff to think about there, but we don't have time to talk about it. So let's just do something. I mean, now that I gave you that little primer, let's do, to me, this is a classic question. You're definitely going to see this on a test, and I think I said this before as kind of an introductory concept, but let's just do another example. And I'll say, I don't know if this is the right example, but I'll say you shoot an arrow up. And because these equations model how things fly through the air, this equation is similar because this is just projectile motions. That's one of the big things you study. And so we'll say this time the height as a function of time is equal to negative 16t squared. That's because you're on the Earth. That's the same exact that's in every single thing you throw in the air. If you throw a rock, shoot a gun, anything that flies through the air, that's Earth pulling it back down right there. But then there's a couple other things. This one has a plus 100t in it. Last one didn't have a t in it. And then this one has a plus 8 in it. Last one had a plus 76. Notice gravity pulls down. It's negative 16t squared all the time. 176 was how far the person was above the ground, right? Well, that's no different here. The 8 is how far it was above the ground. So if I pulled an arrow, maybe the arrow gets let go and I'm 8 feet over the ground when I let go of that arrow because I'm tall or whatever, and my hands are up over my head. Anybody know what the 100 is?
Initial velocity.
Yeah, 100 is the initial velocity. Why was there, how come that wasn't in this problem?
Because he just immediately started falling.
Yeah, he like stepped off a building. If you step off a building, you have no initial speed. But this arrow was shot from the ground. And so when you let go of the string, boom, you have this initial. And so it got shot up in the air. So it's going to go up and come back down again. And so again, because of both algebra and calculus, and you've seen this example before, this is a mainstay in algebra classes. you should be able to find all kinds of cool things about this, like what's the maximum height that reaches and how long is it in the air. But again, we're looking for calculus here. And so although I want to go review all that other stuff, like can you still do algebra? Can you find the maximum height? Well, let's even talk about that. But the key is change of h over change of t, what we often call h prime of t, is just like the last time going to tell us speed. And so we can find the speed, not just the location. Does it make sense? H of t is location. This is telling you, and not location left and right, only up and down. But there's just all kinds of cool stuff that we can do with this. I'll say this is the initial velocity, and I'm even going to write feet per second. So just like last time, we know that units are feet, h is feet, and time is seconds. So could I ask you all kinds of random, algebra and calculus questions? And so we weren't even going to answer all these, but just to make sure that you understand the myriad of things that you should be able to do with this now, which again is really cool. I mean, to think that you could stand outside, and I think this is even more interesting for a gun. On the side of the box of bullets, I showed you bullets yesterday, but it'll say things like this bullet has a velocity of 1,400 feet per second. So that's its 100. So if I shot a bullet in the air, it's like, God, how long is it going to be before that thing comes back down? How high does it go? It's like, those are darn interesting questions. So I don't know. I'm just, as I said, we're not going to necessarily answer all these because some of these are algebra questions, but what's its max height? What's its speed? I just asked this randomly, but I don't know, like at time equals 9 seconds. Like how fast is it going? That's a calculus question. What's the total time that this thing is in the air? That's an interesting question. I don't know, what other interesting questions are there? That's the first ones that jump to my mind. What else do you see? I suppose speed at the ground would be interesting. And you think about this like, hey, this arrow is like that kayaker, except for it's going to be higher. And this arrow is going to go a lot higher than 176 feet. So I wonder what its speed at landing is. Like, is it going to be, faster than the previous one? So but let's just play around with some of this stuff a little bit. Somebody tell me this. This is a really interesting question, but how could you use calculus to answer the first question? You may have some ways from Math 111. If you do, I bet you forgot them, but how could you use calculus to answer number 1? So this is really interesting. And that's probably the single most interesting question here. Would you agree with that? How high is this thing going to go? That feels to me like the most single interesting question. And yet the answer to it's a calculus question. But why is it why does calculus allow us to answer that?
You can set the derivative equal to 0.
Why? You're correct. Why is that? That doesn't make any sense. Where'd you get that from?
Because the tangent line is just going to be a flat line at the peak. It's just the slope's going to be 0.
Yeah, and that's really because what's the speed? It's the weirdest thing ever, but it's like if you're standing next to this person, they shot the arrow, or even if you're up on a bench and it went flying by you, you probably wouldn't be able to see it. It's like, phew, goes by. But what if you were standing way up there at the top, like you were in a helicopter or something, and the arrow came right up to you and then turned around? Doesn't it actually stop? Like its speed at the top is 0. Does that make sense? At that height, it's just interesting to notice that at the max height, the speed is equal to 0. And because speed is derivative, then if I set the derivative equal to 0, that's how I can find that, which is, again, just amazing. So let's see if we can answer that. Like, to me, this feels like a really good test question. Like, if you can't do this, then you're missing the whole point of calculus. This is really cool stuff. Let's see. So h prime of t would be negative 32t plus 100. And again, maybe in a physics class, somebody asked you to memorize that that number was the initial velocity, but notice it's because of calculus that that's the case. At time 0, doesn't that leave the answer to h prime equal to 100? And so h prime is the speed, and so the speed at time 0 is 100. That's why it's the initial speed. Like, it's calculus that told us that. It isn't that somebody just decided to define the number in front of t to be speed. Calculus told us it's speed. That's why. So of course, what we're interested in though is, when is h prime of t equal to 0? And so notice when I get this, what I'm getting is not the maximum height. I'm actually getting the time. That's kind of a bummer. Like, I wanted the maximum height, and I'm just getting the time. That's the only axis I have here. So let's see, if I subtract 100 and divide by 32, I get 3.125. Notice it's kind of cool. This came out exactly correct. And so I get t equals, not approximately, because I didn't get a decimal that goes on forever here. So that's kind of cool. So it's also a little interesting that that's the same 3 seconds that Tyler was on this waterfall. I don't know if that's any coincidence, but how am I going to get the height? Like, the whole goal was to get the height here, and unfortunately the only thing I had access to is time. What do I do?
Would you not just plug it back into the derivative?
Not the derivative, because if you do that, you're going to get 0. In other words, h prime of 3.125 should be 0.
You plug it into the original equation.
Yeah, you have 2 recipes here. One of them tells you height if you know time. The other one tells you speed if you know time. So you have a speed time relationship and you have a height time relationship. And so if you go back to the height equation and put, and again, this is why function notation is so cool. Notice how easily I can say that. If I go back to that original problem, so now I'm sticking 3.125 in, so negative 16 times 3.125 squared plus 100 times 3.125 plus 8. I got 164, again, equal. I didn't have to round it off. I got 164.25. And if you don't say feet, you should lose points, because like the whole point of this is actually to find the height. And if you just say 164, like what, meters, years, days? So I now actually have an answer to that. And so that's interestingly, and maybe you're not surprised by this. Well, actually, I'm a little surprised by this, because I thought I was going to go way higher than that. I thought I was going to go like 600 feet in the air. It's like, what? That stopped pretty fast. And I think the reason is because I don't think an arrow is a good example here. I think the initial speed of an arrow is way more than 100. So this actually took less time to get there, just like less time than Tyler's jump off the waterfall, and coincidentally also a little bit less in height. And so this actually just made it up to the bottom of that waterfall. So this feels more like somebody throwing a rock, not an arrow. So I think 100 is not realistic for that speed. But notice it's actually calculus that gave us that answer, which is kind of cool. Would you agree that number 3 is not a calculus question? It's just an algebra question? Why is that? How would you get the total time in the air? What's the technique in algebra to figure that out?
Would you isolate t from the original equation?
Well, the key is you're there, right?
Oh,
The ground, you're there. What do you know about there?
it's it's an X intercept.
Yeah, you know the height is 0. That just turns out to be, this is the third time that's come up in our discussion today, entirely just randomly. It was a part of the shadow question in here too, but that's kind of what I mean about speaking the language of algebra. If you memorize it, it's like you got to draw pictures. You got to think about it. I sort of have two equations here. One tells me the relationship between height and time. The other tells me the relationship between speed and time. And so I have to see total time in the air. The code is, oh, when does it hit the ground? Like I got to come up with that myself. And when it hits the ground, I know that H is 0. And so I could put H is 0 in for this equation right here, and then I'd have this quadratic equation to solve. And so that's not a calculus question, as it turns out. When you leave this class, you shouldn't even have to think like this. You should just think math. That's what happened to me on that shadow problem. I just thought math. How do I figure this out? And whether it involves algebra or whether it involves calculus, like those are two languages. I know English, I know Spanish. And so I can get stuff done in both of those worlds. And, you know, if you're really good at both those languages, then they're almost interchangeable to you. And you can even think in one of them. You're not going to get that good in one calculus class, but I'm just saying that's the goal. You see what I'm saying? To be able to speak the language and just get stuff done. And so you sort of had to speak Spanish to get number 3 done. But the other ones involve speed. And so, you know, they're derivative related statements. Of course, speed at any time you want is easy. You just go, you know, stick in whatever time you're interested in, right? Does it make sense that you'd have to answer this algebra question here in order to be able to answer this last one? Because wouldn't you have to have H of, well, the time that this thing was in the air? Like, wouldn't you have to know how long it, like what time it was when it landed? So it turns out if you never asked question 3, you'd actually still have to create the question 3 and answer it to even know what time to put in there. I mean, isn't that kind of interesting? So I was just randomly throwing these questions out here, but it's like they all kind of mix together and you sort of need them all.
Didn't you solve 3 with the quadratic formula?
Mm-hmm.
Because that'll give you your 2 X intercepts. And obviously the larger one would probably be the total time.
Yeah, so just to leave you with the answer, I'm going to throw negative 1608 into the quadratic formula. So I guess I'll just write this here. Quadratic formula, A equals negative 16, B equals 100, C equals 8. And I got 2 times. And one of them was negative 0.07. That's weird. Wouldn't it be times 0? Like, didn't it leave the ground at 0? Well, the answer is no. It started at 8 feet in the air. And then it actually went up and then it came down and hit the ground. And so does it make sense it hits the ground back in time, if you will, in the pattern? So it actually makes sense that that first time would actually be a tiny negative number. I got negative 0.07. I'll just say negative 0.1. And then the other answer I got is 6.33 approximately. So it's like, oh, 6.33 seconds. That's how long it's in the air. So if I take that 6.33 and plug it in there just to give the answer to this, because it's kind of cool, that'd be H prime of 6.33. And since H prime we said was listed right here, then I say negative 32 times 6.33 plus 100, negative 102.6. .56, but I'm going to round it off to 6. And that was a speed, so this is feet per second. How come it isn't hitting how come it doesn't hit the ground at the same speed it left at? It left at 100. Why wouldn't it come back and land at 100? It's like it's converting in physics kinetic energy to potential energy. And now there it is parked in the sky way up there in the air. Doesn't it just spend all of that and then come back and be at 100 again, like when it hits the ground?
Well, you have the effect of gravity, right? So it's added acceleration, pulling it back down. Whereas firing it, you have gravity pushing against it.
That's partially true. But if it left from the ground like a golf ball, if it left from the ground and it came back down, it would be going exactly the same speed as it left at. Whatever you hit it at, gravity will pull it back down and add all the energy back in. It'll go exactly the same speed. But this didn't leave the ground. It left it 8 feet higher. And so right there was at 100, which means right there, it's also at 100, but then it has 8 more feet for gravity to pull on it, which is why it sped up just a little bit above that. Can you speak the language of calculus? In a sense, that's a flavor for questions that you're going to see in your assignment. I don't think your assignment questions quite make it. I don't know if fun is the right word, but I was attempting to make that just a little bit more interesting and play around with all kinds of things to help you understand the language of calculus. I want to take just a quick look because we got a few minutes left to see if there's one other question I might want to try to squeeze in here. I just have a note to myself that there's some questions in the book that, because I want you to be prepared for the assignment. So now let's do this one. Actually, I got one of my you may remember E shows up for continuous growth. And so, and again, I'm going to use real letters. Let's even, I was going to say A for amount, but let's go population. Population of a town, and it's always nice not just to say P, but P is a function of T, which means the equation that follows is just going to have T's in it on the other side. And so what if it was, say, 1600 e to the negative 0.07 t. The fact that there's an e there should not surprise you from Math 111 because that's continuous growth. What does it mean that the percent is negative though? The 0.07 is negative.
Does that mean it's decaying?
Yeah, it means it's not really growth. It's actually dropping off. And figure this out real quick. What's P of 0? Notice we haven't taken any derivatives. What's P of 0 in this case? If you put 0 in for T, what do you get?
0.
You don't get 0. Think about that a little more.
1600.
You get e to the 0, which is actually 1. And then 1 times 1600 is 1600. So what does that mean? What does that tell you the meaning of that number in the front is? You might have memorized this in Math 111, in which case you forgot it. But what does that tell you that original number means then?
Is it how large the population was at this?
Exactly. That's like your initial investment if this is money, or that's your population, your initial population. And when I say initial, by the way, it could just mean now. In other words, it doesn't mean the town started with 1,600 people. It just means today is the day I'm going to start looking at this, and I want to see what happens from here. And so it's like the population initially is like right now. Did I freeze there for a second? Looked like Poppy froze, so I happen to be looking at Poppy. So again, my question is, what does P prime of T tell you here? Why would somebody take a derivative? P of T tells you the population anytime you want. That's an algebra problem. So if we plug in T as 19, or the kinds of questions you should be able to answer is like, how long is it going to take for this population to drop down to 1,200 people? That's an algebra question. But what does calculus add to this? Why would you find P prime of T? And again, all you have to do to answer that is to say, well, a better way to say P prime of T is just to think change of population over the change of time. Oh, that's telling me speed again. It's the speed, like how fast is the population changing? How quickly is the population changing? Are we losing like 10 people a day, or are we losing like 50 people a day? So I can know the population anytime I want, but calculus allows you to talk about how it's changing. So, and this, you don't necessarily know this yet, but what's the derivative of e to the junk? What's the derivative of e to the x?
It's just EX.
It's just e to the x. But that's not just e to the t. There's a 0.07 there. And so it actually turns out that you also, and we saw this a little bit in something I explained to you before, but you actually have to take that 0.07 and multiply it by 1600, whatever that number is there. So negative 0.07 times 1600 is negative 112, but I'm going to write that whole thing out. So you actually have to take that and multiply it by 1600. And so you get negative 112 e to the negative 0.07 t. And what I'm trying to get across to you is just that you now have two cool things. And so let's just quickly answer, let's just say one interesting question. Like somebody has these two equations and they just say something like, well, gee, I'd like to know what the population is 7 years from now. And so we'll say time is in years. T is years. So, you know, this is a person just doing algebra, and this is the easy question, by the way. So I just say, okay, great, plug in 7 for t. So I say 1600 times e raised to the negative 0.07 times 7. And I get 980. I get approximately 980. And so this person is saying, wow, you know, in 7 years then, at a 7% decrease in population per year, we're going to be down to 980 people. That's really interesting. That's a wonderful question. Why is this also an interesting question? And do you understand what that's telling you? And I alluded to this a little bit yesterday as well, but like, you know, why is that a second thing somebody might want to know if their whole focus is on what's happening 7 years from now?
So is P prime of 7 telling us how fast the population is dwindling at 7 years exactly?
Exactly. So remember, the derivative tells you the speed any place you want to go. It's a formula that tells you the slope or the speed any place you want to go, the rate of change, not so much speed anymore. This is speed worked good for arrows, but you wouldn't say speed here. You'd say, well, rate of change. And so, yeah, in this case, I'm interested in 7. So if I just go back and stick 7 into our derivative equation, I'm doing that now. I get about negative 69, rounding it off. But again, if you don't put units in that, then you have a hard time understanding this. And if you don't go back to, this isn't P prime so much as change of P, oh, that's population, and then it's over one what? Over 1 year. And that's a positive 1. So, oh, at year 7, we're actually losing 69 people a year. That's the rate at which the population's changing right then. And we'll get a different answer if we go to a different year. So not only do I know now that there's predicted to be 980 people, that's an educated guess. That's not what'll happen, because the rate of change is going to change. I mean, even the 7% is going to change. And so life is a lot more dynamic than this. But our best guess now is that there'll be 980 people. And we even know that the rate of change at that point is like 69, which means next year there'll be around 69 less people than that. And so you see how they're both cool? Like, you need to know them both. This is what calculus adds to the discussion.
What would be a good way to find out how many, like a month? Like, could you dwindle it even further?
Yeah, on a particular month, you just have to say, well, like if you wanted month 3, that'd be 7 3/12.
Okay, that's what I was thinking. Cool.
Yeah, good question. So stay after if you like, because I want to let you go, but tomorrow's test, I'll give you plenty of time because I want you to have time to check your work, but I am going to tell you how much time you have. I'm going to effectively, you're going to take this test at home. I'm going to ask you to be on your honor to do it. I want you to scan it. I have some of you got the scan thing figured out, but it is really important for you to scan it. as a PDF file and give me one file that has them all in there, because I want to be able to grade this and get it back to you. It's just really hard for me to get like 9 pages from you, and then they're all individual and I'm bringing them all up one at a time and so forth. I say that for your sake and mine, in the sense that I want to get it back to you the next day, but also respect my time by, you know, doing what you can to help me do that. Help me help you, if you will. But I will post it in my open math tomorrow morning at the normal class time.
And is this going to be kind of like the quiz was, where we download the PDF, print it, and then scan it back to you?
Yep. And it will, if you don't have a printer, you don't have to, you can just look at it on your computer and do the problems on a piece of scratch paper. It makes it a little, probably makes it, if you can print it, I would. It makes it a little easier for me to grade faster, just because it looks like my key. And then, you know, some of the stuff you need to know is just sitting right there and so forth. But I don't really care, as long as you say this is question 1, question 2, and so forth. And then I'm also gonna, you get the notes that you have right now, which is, you have a note that tells you what the product rule is. You have a note that tells you what the quotient rule is. You have a note that tells you what the power rule is. Like, you get those notes on every test, but that's all you get. Like, you're not online, you're not doing this with somebody else, etc. And I'm going to ask you to sign a little integrity statement at the start of this. I like this method because I don't feel that my job is to police you and babysit you. I hope you want to learn and be awesome instead of just cheat your way through this anyway. So I actually like giving this kind of freedom to people. I think it's cool. You have to live with it if you're not able to handle that. But
is that during the normal class time?
Yeah.
Okay, so are we also allowed to use the trig notes?
Yep.
Okay.
Yeah, and I'll say that on that. Everyone will be different, but yeah, you get the trig sheet, and I have both the trig sheet and that posted in my open math. And so hopefully you already have it printed, just because it's easier to, you know, have in front of you when you're doing an assignment than to pull it up electronically. But yeah, the notes that I have posted in my open math will always be what you can use. So I probably won't resend those.
Is it going to be timed and proctored on Zoom?
So no, what I'm not going to do is sit here and watch you take the test, because I'd rather extend the trust to you and just have you, we don't even talk tomorrow. Like, you just pull it up and sit at home and do it. And even with respect to 8 o'clock, like, if you want to start it at 8:30, fine. I want you to do it during the normal class time, but it's like a half hour either way. So what? So I'd rather you just be able to be a little more peaceful about it. You know, if I'm taking a test, I don't want somebody staring at me like when I'm taking it. So, yeah, and I probably should do that, just because it obviously makes you a little bit more accountable. But I'd rather just extend you trust and you respect that and earn it.
And when is this test due again?
I'm going to give you, I'm still making it, but if I made it a little too long, then I'll give you more time if I make it a little too short. But I'm thinking it's normal class time, hour and a half, except for I probably would make it 2, just because I want you to have time to check your work. But again, that kind of depends on how many questions I ask and how complicated they are. So, I mean, think of it as about a 2-hour test. That's probably what I'm going to do. And then if you're on the ball and don't choke and so forth, you'll get done. But I might make it an hour and a half, and then, you know, make the test it should take you an hour, but I'm giving you an hour and a half. So, but I'll say that it'll be part of that sort of first question where you say, you know, I'm not going to look at other stuff. I'm only going to use these notes. I'm only going to take 2 hours. Like, I'm going to say all that stuff on there just to make you think about, you know, what you should be doing before you do it. So ideally you just scan it right inside there. Some of you were successful with that first quiz and some of you weren't. I'd rather you just, there's a link right inside my open math, like that test is an assignment, and you go in there and open it, and there's a place where you can scan it and then get it on your computer and then link it right in, and I get it in my open math as opposed to an email. But if you have trouble with that, because I don't know what this looks like from your perspective. So if you have trouble with that and you email it to me, that's okay too. But I can believe that's a good way to do it now.
Go ahead, Faith, sorry.
Thanks. Where are the trig notes? Like the ones that we were supposed to print a while ago?
They're in the course. What did I call it? Course something.
Okay, thank you.
So for the quiz, I was able to like go in and download the PDF, but I couldn't find any place to like turn it in. That's why I just emailed it to you.
Yep. And you weren't the only person that
There's
said
two
that.
parts
Like
to
some
the
people
question,
found
is
it and
where
some
you
people didn't. So I don't know what I can't see what you guys see. So
When you
anybody have
go
any
in
thoughts on
there,
that?
when you go in there, there's one spot where you actually download that file, and then there's another spot where it says question 1 or whatever. You go into question 1, and then it'll give you the ability to upload one or multiple files, I think is what it is.
So that's not very clear because
It's
question
super
one
weird,
doesn't say.
like,
Yeah. Poke around in there a little bit is the answer. Like, see if you can figure that out. Poke around in there a little bit and see if you can send it directly back through My Open Math. But again, I don't want to turn this into a technology class. It's like, if you spend 5 minutes and give up and email it to me, fine.
Sounds good. Thanks, Doug.
Yeah, I would
Right.
just look for that question thing, because that's how it was at least last term, last couple terms when I've been turning stuff in like that. It was like you'd go in there and then it would give you, the place where you download the PDF and then a question. And then once you open that question, it's like, oh, this is where I put it.
Yeah, like question 1. It's like question 1, but it's not question 1. It's the whole paper that you just downloaded. And so you're answering question 1 by
Right, by uploading your.
uploading. Thank you for that, Justin, because I can't see what you guys see. So. Stay after if you want to ask me questions. Otherwise, we'll see you all tomorrow.
Bye, thank you.
I just had a quick question,
Yeah, go ahead.
Doug. So tomorrow for the test, you want us to do it like during the class period normally?
Pretty close, yeah.
Okay, gotcha.
And part of that's because I actually want to get it back to you tomorrow.
Yeah,
There's a part of me that says do it tomorrow, and that would give you some convenience, if you will. But if I don't get it back to you, if I don't get it back from you, like, at the end of normal class period, then I'm not going to have enough time in the day to grade it. Because like I said, I spent like 6 hours grading stuff yesterday because I spend forever trying to come up with what you did wrong, and so you can learn.
I get you.
Um,
I got you.
Anyway, yeah.
I've had a ritual since I've kind of been doing these tests online, so I was hoping I could stick to it. But if that's the way you want to do it, that's your class, not mine.
If you have some issue, email me and
Well, I normally like to for every one of these tests I've done since we've been online, I like to sit down and start my morning with going through the review to kind of refresh everything in my head and then do the test immediately after. But I can just do it tonight.
if you have a request, email it to me.
Okay.
As much as I can, I'd be happy to accommodate your.
Yeah, I'm there with Andrew, but the thing is, I could probably just do it tonight, because we've been doing that kind of same thing. We don't do it together, but we ended up realizing that we did do the same thing because we've actually taken every single math class together.
Yeah. Uh-huh.
It's no big deal. Let me just figure out what my schedule is for tomorrow because I have my kid and everything, and then I'll let you know, Doug.
Yeah, but if you went from 8 to 9 and then started the test, it's like, is that going to be close enough? Well, probably.
Yeah. So yeah, I'll get it figured out. Thanks for being willing to work with me. Appreciate it.
All right.
I'm assuming you got my emails last night, correct?
I haven't looked.
Okay.
I will look right now just to make sure.
For some reason, I don't know why, I thought that the project 1 was the quiz, and I think it was because when I went on to My Open Math, I didn't see anything that said project 1, so I thought they were the same thing, and I didn't even realize that the quiz was a thing until yesterday morning. Because I didn't look in it.
I did see that email. Yeah.
I did the quiz. I know almost all of it's right. I checked all of it on Desmos as I was going through, and I emailed it to you at 6. I understand if you can't give me credit for it or whatever, but
I have no problem with that, Justin. I don't care.
Okay.
That's no problem. I only said that for the same reason, which is if I don't get this grading, get it back to you before the test tomorrow, then it does you no good.
Right.
If I get it too late in the day yesterday. But again, that's kind of more like if I got yours late, and especially because you emailed me, like you had some respect for, my time, and just like I do for you, that you would say, and you did that. You're like, hey, screwed up, I got no problem with that. Great. Perfect.
Okay,
Yeah.
sounds good. That actually helped me a lot. So thank you. Have a good day.
Yeah, you too. Take care.